So let's see some sums on Classful IP addressing. So summary table is given. Class A, the leading bit, that is your starting bit, is 0. Net ID 8 bits are reserved. For host ID 24 bits are reserved. You have start address and end address. Number of networks 2 raised to 7. Addresses per network 2 raised to 24. Class B starting bit is 10. Net ID bit 16. Host ID bit 16. Number of networks 2 raised to 14. Addresses for the networks 2 raised to 16. Start address 128.0.0. 191.255.255.255. Class C starting bit is 110. Net ID bits 24. Host ID bits 8. Number of networks 2 raised to 21. Addresses per network 2 raised to 8. Start address 192.0.0.0. End address 223.255.255.255. Class D leading bits 1110. Start address is given and end address is given. Class E starting leading bits are 1111. Start address 240.0.0.0, 255.255.255.255. This is your last address. Now what have they said? Convert the following addresses in another notation and find the class. Another notation means this is given in binary. You have to convert it into decimal. Simply you will be putting in the calci decimal conversions of each of them. This also you have to convert into decimal. This you have to convert into binary. And this also you need to convert into binary. So first we will see what is the class. Starting with 110, we saw here starting with 110, class is C. So class C. Starting with 0, we saw class A. Class A starting with 250. For 250 comes in the range of 244 and 255.255.255.255. So at 250 we will write class E. 132 comes in the range of class B. 128 from 128 till 191 is your class B. So this is class B. From 128 you have it till 191. Next, find the subnet mask, net ID and host ID of the following IP addresses. So how to calculate this? 117. First identify the class. You have class 117 is between 0 to 127. So class A. For class A, net ID bits are 8 bits, host ID is 24. So net ID is 117. Host ID is the next 24 bits, that is 34.3.8. And subnet mask. Subnet mask. How to calculate the subnet mask? For subnet mask, the rule is that all host ID bits will become 0 and net ID bits will be 1. So if you do that, what you get? You get 255.0.0.0. When you convert all the 8 bits to 1, you get, in the decimal notation, you get 255. For 1, 2, 3, 4, 5, 6, 7, 8. 8 ones decimal number is 255. Now 132.57.8.6 belongs to class B. Net ID is 132.57, the first 16 bits. Host ID is the next 16 bits, that is 58.6. Subnet mask, all the net ID bits I will convert into 1. So I get 255.255.0.0 host ID bits converted to 0. Now 207 comes in your class C. So this is class C. In class C, net ID is the 207.3.54. Host ID is my 12 and subnet mask is 255.255.255.0 is my subnet mask. Next, given the network address as below, find the class, block and range of address. So this is belonging to class A. 17.0.0.0 till 17.255.255. This is your range. And block is 17. What is the block? Block is your net ID. For this, class is B because it lies between 128 and 191. Range is 132.21.0.0 till 132.21.255.255, and my block is your net ID, that is 132.21. In the next question, let me erase this part. This belongs to class C. Class C is 192 to 233. Then range is 220.34.76.0 till 220.34.76.255, and block is net ID, that is 220.34.76. So this is the way we will solve for class, block and range of address. So given a network 17.0.0.0, find the class, the block and the range of address. So how to write the solution? The class is A because the first bit is between 0 and 127. 17 lies between 0 to 127. So we say class is A. The block has a net ID of 17 and the address range is from, so the starting address is 0 and the last address is 255. So total there are 256 bits. So how do we write the range? We write 17.0.0.0 to 17.255.255.255. IP address to network address. Find the class, then the net ID, then set the host ID equal to 0. Example, IP is given 134.45.78.2 is a class B. Why? Because it lies in the range of 128 to 191 with a net ID. Net ID is the first 16 bits, that is 134.45. So its network address is 134.45.0.0. So network address is what? The net ID bits. Use a mask which is 32-bit binary number that gives the first address in the block when the bitwise and with an address in the block. So an address in the block, when you perform the AND operation, you get the beginning address. Then default masks are given for A. You have 255.0.0.0. That means the first 8 bits are set to 1 and the next bits are set to 0. The next 24. In class B, first 16 are set to 1, next 16 are set to 0. So network bits are set to 1, host ID bits are set to 0. In class C also, the net ID bits are set to 1, host ID bits are set to 0. So when you set the bits to 1, you get, when you write 1, 1, 1, 1, 1, 1, 1, 1, that means there are 8 bits. Then your decimal equivalent is 255. Given the address and the default class A mask, find the beginning address. Beginning address is also called as the network address. Network address you get with the help of the net ID bits. Net ID in case of class A, the first 8 bits are net ID bits. So your network or the beginning address will be 23.0.0.0. So how do you write the solution? The default mask is 255.0.0.0, which means that only the first byte is preserved and the other 3 bytes are set to 0. So first byte, that is the first 8 bits, are preserved, other bits are set to 0. The network address is 23.0.0.0. Now given the address and default class is B, find the beginning address. Now default class is B, so set the net ID bits to 132.6 and host ID bits will be set to 0. So the default mask is 255.255.0.0, which means that the first 2 bytes are preserved and the other 2 bytes are set to 0. So first 2 are preserved, you will write them as it is, and the other 2 are set to 0. So basically what we are doing, we are setting the net ID bits same, whereas the host ID bits will be set to 0. So net ID is preserved and your host ID is set to 0. You get the network address. Next is, given the addresses, find the beginning address. So it's given 200. 200 comes in the range of 192.2233. That is your class C. So in class C, we know that the first 24 bits are your net ID bits and the last is your host ID. So net ID bits are preserved. So first 3 you will write as it is and the last one we will put a 0. Given the network address, find the class, the block and the range of the address. So you will say class C by, because it is in the range of 192 to 233, block of net ID is 220.225.35 and your range will be host ID bit set to 0. So this till when your all the host ID bits are set to 1, you get 220.25.255. So net ID is preserved. Whatever is happening with the host ID bits. Subnetting. If an organization granted a large block in class A or B, it could divide the addresses into several contiguous groups and assign each group to smaller networks called subnets. Subnetting increases the number of ones in the mask. Supernetting. Supernetting is opposite of subnetting. In subnetting, a single big network is divided into multiple smaller subnets, while in supernetting, multiple networks are combined into a bigger network termed as a super network or a supernet. So when a single big network is divided into smaller networks, we say subnetting. When smaller networks are combined to form a bigger network, we say supernetting. Example, suppose organization needs 1000 addresses, 4 class C blocks can be granted. Several class C blocks can be combined together to create a supernet. Supernetting will decrease the number of ones in the mask. Subnetting will increase the number of ones in the mask. Point number 1 of difference. Second point of difference is in subnetting, small networks will be combined to form a bigger network, whereas in supernetting, multiple networks will be combined to form one big network.